Today we'll be going over how to set up your first training experiment. We'll be fine-tuning a model for a specific task. For the sake of this video, we'll keep it simple. We'll fine-tune a model to learn how to translate phrases using a given cipher map. Once you sign in, you'll see your experiment dashboard, except there are no experiments yet. So to get started, let's go ahead and open the template notebook. Now you'll see our experiment template notebook on Google Colab. We use notebooks to set up and launch training experiments. Go ahead and clone this to your own drive. Now that you have a copy, go ahead and run the setup cells. The first one just installs dependencies from the CGFD repo. This might take a minute or two. Once that's done, you'll need to get your API key set up. You can grab one from the experiment dashboard. Just go to your user settings down here and generate a new one. Paste that in and then give your experiment a name and a prefix. These are just to label your experiment, environment, and dataset on the dashboard. The next step is to construct your dataset. These are the prompts and any other supplemental information used to train your model. This can come from any existing dataset, or it can be synthetically generated. For our cipher swap example, we're going to need to synthetically generate input strings along with its corresponding cipher mapped output phrase as a reference answer. I won't bore you with writing all the generation code out, so I'm just going to paste some code I already pre-written to basically generate prompt answer pairs. You can see here I have my cipher map saved as a dict, as well as a helper function to apply the cipher map to some text. The next pieces are what we use to generate the actual input prompts. It's important in RL to make sure you have a diversity of inputs so that the model learns and generalizes well. So I have one function that generates a random assortment of characters, and I have another function that just generates a phrase of 3 words from this word pool. So now that we have those helpers, we'll populate our dataset. I'm going to first loop over however many samples we want. Then I want it to randomly select the word bank method 50% of the time, and then the random string method 50% of the time. Once we've generated the input prompt, we'll go ahead and add it to our dataset along with the reference answer. The template code here will automatically split your dataset into a training set and eval set with a default split of 70-30. I'd like to do some quick spot checks just to make sure everything went okay. So I'll go ahead and insert some print statements here. And looks good to me. The next step is to set up the environment, which defines how the model is evaluated during testing. First, we'll set up the system prompt. This is what is sent to the model to give it context at the start of every rollout. I'm just going to paste what I already pre-written down here, but basically it's just giving context for the task, the reference replacement map, as well as constraints for formatting. Up here, you can see we already have a helper function in the template to extract the answer using the formatting we have in the prompt. And then now we'll talk about extending the environment class. So here's the template. You can just rename it to whatever you want. We're going to call it cipher swap env. You can see we're loading in the system prompt. The init method, you're going to want to just add any env level setup here. Because we're doing something simple, we won't really have to do that. The dataset preprocess function basically just maps the dataset into a standardized format. So you can see the prompt gets passed to the model, and any other additional arguments like the ground truth also get passed to the reward function. The next two functions define the tools that the model has access to, but because we're doing a simple cognitive tasks, we won't need this. Last and most important is the reward function. You can see in the completion parameter here, this will be populated with the model's raw output, and ground truth is used for the reference answer. All right, so let's go ahead and write the reward function. First, I'm going to set up the score, default score of 0 if it gets it wrong. Then I'm going to go ahead and use our helper to extract the answer. Basically, it will extract anything inside those answer tags. And now we're just checking if the model answer matches the ground truth. We'll reward it a score of 1. And if not, it'll be 0. We'll make sure that gets added to the reward dict, and we're going to return it. We return rewards as a dict because to support composite rewards where we may want to have multiple scores. For example, maybe conciseness matters or number of tool calls. For the sake of this example, we'll just keep it simple with just a simple binary reward. The last step is just to submit the training job. So we're going to need to edit the environment class to the new name. I forgot to run the above cell, so I'm going to go ahead and do that to actually define our environment. All right, so let's go ahead and run this cell to submit our training job. Oh, it looks like we forgot to run an earlier cell, so I'm going to go ahead and do that. Now everything should be defined and it should just work. So it'll first upload the dataset and environments, then it'll run some local validation as well as some remote validation just to make sure everything is good before actually starting training. This might take a minute or two, but usually not too long. Oops, looks like we have some errors here. Example is missing required prompt field. Oh, this is because the trainer expects the dataset to have prompt as the field, but we had labeled them as question. So we'll go ahead and fix that and then rerun both cells, and hopefully it should work this time. All right, looks like that worked. And now we have the experiment link, and we can go ahead and open our experiment. Once you've launched a training job, you're going to have to wait a bit before you see any results as the GPUs warm up to pick up your job. I'm going to check again in an hour or two just to make sure that there's been enough time for the model to have completed several training steps, and we can check on the progress. All right, it's been 2 hours, and now you can see 75 steps have been completed, and the training has sort of plateaued. You can see the average reward is very close to 1, so that's a really good sign. If you scroll down to the rollout deep dive section, you can inspect any individual prompt to see every single rollout the model has tried over the course of its training run. This is really useful for debugging any issues, seeing what the model learns well, seeing where it doesn't. If you navigate over to the eval tab, you can see how the model performed against the evaluation set along its training runs. You can see here it's getting also very close to 1, so that's a great sign. If you want to see how this compares to external models, in our comp tab, you can evaluate performance on the same evaluation set by other models. And that concludes our tutorial on setting up your first training experiment. I hope this inspires you to get started on fine-tuning a model for whatever your use case might be. We'll also soon have tutorials for training a RAG agent on your data, as well as tips and tricks for experiment design, iteration, and debugging. So stay tuned.